over and let's do this. Okay, so y'all, the last thing that we're going to talk about in our class is 8.4, which is something called the normal distribution. Okay, so in the normal distribution, this is when we talk about standard deviation, which was kind of like an average of how far every number was away from the average, right? We talked a little bit about that last week on Wednesday. So we have something called the 65, 95, 99.7 rule for the normal distribution, okay? And so what it says, y'all, is that about 68% of the data items fall within one standard deviation of the mean. About 95% fall within two standard deviations of the mean, and about 99.7% of the data items fall within three standard deviations of the mean. So y'all, I'm going to kind of explain this idea by going through the first problem that I got here, okay? And look what it tells me. It says scores on a test are normally distributed with a mean, remember the mean is just the average, of 130 and a standard deviation of 30. It says find the score that is one standard deviation above the mean. Okay, so y'all, what I have right here, I have the same chart that we were kind of looking at, right? So y'all, remember, X bar is my mean score, which is 130. So y'all, right here in the middle, right here where that little X bar is, right underneath it, my friends, I'm going to write down the number 130, okay? The second thing it tells me is that my standard deviation is 30, okay? So y'all, we want to find a score that is one standard deviation above the mean. When it says above, y'all, that just means more. So what we're going to do is we're going to say, look, the distance between here and here is 30. And it's why it's 30? Because they told me it was 30, okay? So we're really looking for that number right there. So y'all, I'm just going to take 130 plus another 30, and that would be 160. Okay. Above the mean, y'all, just means more. Okay. So that's all we got to do. Look, we're going to try another one. We're going to keep it real easy breezy, cover girl. Here it says the scores on a test are normally distributed, again, with a mean of 130, but now my standard deviation is 20. Okay, so the first thing I'm going to do, y'all, my mean is 130. So right here in the middle, I'm going to write my number 130. Okay. They told us that our standard deviation is 20. So the distance between here and here is 20, and that's another 20, and that's another 20. Okay. What we want to do is we want to find a score that is two deviations above the mean. Remember, above, y'all, just means more. So I'm going to take my mean score, 130, and I'm going to add 20. That's going to give me 150. I only did this one time, y'all, but it's telling me, can we do it twice? Because it says two standard deviations above the mean. Okay, let's add another 20. And the score that I'm looking for now, y'all, is 170. Okay. Y'all, the other thing we could do here is we could take our number 130, and since they're saying, can we do this twice? We're going to take 2 times the standard deviation of 20. So 130, 2 times 20 is 40. And if we add those together, there's my 170, right? Now, why were we adding? Because it was above, and above means more. Okay. So y'all, look, I'm going to try this again with another problem. Sorry, here we go. And it says the scores on a test are normally distributed with an average or a mean of 150. So again, right here in the middle, y'all, 150. The standard deviation is 20. That means it's 20 points this way, 20 points this way, 20 points that way, right? We want to find a score that is 2.5 standard deviations above the mean. Y'all, again, remember, above just means more. So I'm going to take my average, 150, 2.5. Does anybody know how would you write 2.5 as a decimal? What do you think? What is 1/2 as a decimal? Anybody know? Point. Yeah, two. So yeah, so it would be 0.5, right? So if it's 2, wouldn't it be 2.5 times my standard deviation of 20? I'm going to ask you guys for a flavor. Can anybody take their calculator port, please, or get your phone, whatever you got? Can anybody tell me what's 2.5 times 20? I want to say it's 50, but I don't. I think it's 50. 50? Yes, good. It's 50. Okay, so look, y'all. 150 plus another 50, 200. When we're talking about scores above the mean, they should be bigger than whatever the average is. Why bigger? Again, y'all, because we're talking about more. Okay. So, y'all, just like the way we talk about scores that are above the mean, sometimes we talk about scores that are below the mean. Okay. So if I look here in my next problem and it says, again, the scores on a test are normally distributed with an average of 150. So here we go. There's my 150. My standard deviation is 40. So y'all look, here that's 40, here that's 40, here that's 40, but it's also 40 going in that direction. Now, what we want to do is we want to find a score that is 2.5 standard deviations below. Y'all, below means it's going to be less. So the first thing I'm going to do, I'm going to take my test score, 150. Instead of us adding, we're going to subtract 2.5. That's the number we just used right now. 2.5 times my standard deviation of 40. Okay. So y'all, look, let's do this. 150 minus, let's see, is 2.5 times 40. Is that 100? Anybody got a calculator? 2.5. Yeah, it's 100. Okay, look, y'all. Now what we're going to do, we're going to subtract them. 150 minus 100, 50. So, y'all, when we're talking about scores that are, here we go, that are below, they're going to be smaller than the average, right? If we talk about test scores that are above, they're going to be higher than the average. Okay. So y'all, what ends up happening here when we do these types of problems is that what the standard deviation says is, look, we took, say we all took an IQ test, right? We all took an IQ test, right? And we scored or the average score was 150. Some people scored higher than 150. Some people scored less than 150. Since the standard deviation in this case is 40, that's telling us that the difference, like one standard deviation above would be 40 points higher, one would be 40 points lower. 2 standard deviations above would be 80 points higher, 2 standard deviations below would be 80 points lower, so on and so forth, okay? So y'all, now let's take a look at the next problem. And y'all, we're gonna basically keep using that same chart, okay? We're gonna be using that same chart here. And so it says, look, not everyone pays the same price for the same model of a car, right? The figure illustrates a normal distribution for the price paid of a particular model of a new car. Okay, the first thing it tells me is the average is 19,000. Look, y'all, that's why that number is right there in the middle. That's 19,000. And the standard deviation is 1,000. Y'all, I want you to notice something. If this is 19,000, look, that's 20,000, 21,000, 22. You're paying more than the average if you're going to the right. If we were to go to the left, the average is 18,000. That means we got a good deal, right? We paid $1,000 less, or we paid $2,000 less, or we paid $3,000 less, right? Okay, now the question says use the 60, 95, or 68, 95, 99.7 rule to find what percentage of buyers paid between 16 and 22,000. Okay, so y'all, what we're trying to do is we're trying to figure out what percent paid within this range. Y'all, if you look right here, what percent paid within that range? Wouldn't that be 99.7%? Guys, when you're doing this, you don't even have to put the little you don't even have to do the little percent symbol, because if you notice, boom, it's already right there. So you're just going to enter in 99.7, right? And that's all we got to do. Okay, let's try another one. We'll do it the same way, y'all. So look, I'm going to scroll down here. Same sort of problem. Okay, same sort of problem. Again, not everybody pays the same price for the same model of car. Okay, the mean in this case is 15,000. So if you notice, that's the number in the middle. My standard deviation is 1,000. So again, if I'm paying $1,000 more, I paid above the average, right? If I paid $2,000 more, I paid 2 standard deviations above the average, right? Okay, now it says use the rule, this rule, to find what percentage paid between 15,000 and 17,000. So y'all, I'm trying to figure out what percent paid just in that percentage right there. Okay. So y'all, there's a couple of ways we can do this. We're looking for, let me kind of do it like this. Boom. Like this. Boom. Here we go. We're looking for what percent paid in that region. Okay. Now, y'all, let me ask you a question. If we wanted to know what people paid within this region here, would you guys have said that would have been what, 95%? Okay, but we're not interested in that part. We're only interested in this part. Compared to that graph, aren't we just taking half? We're just taking this half of the graph. So y'all, if you take your calculator and you take 95, and you take 95 and you divide it by 2. I'm going to get my calculator here real quick just so I don't have to keep 95 divided by 2. 47 and a half, right? Thank you so much. Boom, 47.5%. And we found it. Okay. There you go. Okay, let's try this, y'all. Let's see if we can do another one similar. Okay, still dealing with the price of the cars, right? Still dealing with the price of the cars. Take a look, my friends. The average is 18,000. Boom, there we go. My standard deviation, still 1,000. We're keeping this real simple. We want to know what percentage of buyers paid between 17,000 and 18,000. So y'all, I really want to know what percent paid in this piece. Well, we know that the people that paid in this region, in the red area, is 68%, right? But aren't we only taking that part of it? So we're going to take that and divide it by 2. And that would give me 34%, right? Okay. Let me keep scrolling down here, y'all. Same kind of setup. Okay, let's take a look. My average, still 15,000. Boom. Okay, here we go. Ooh, but look, now my standard deviation is only 500. Okay, we want to know, use the 68, 95, 99.7 rule to find the percentage of buyers who paid between 13,500 and 15,000. So y'all, we're looking for what percent paid in that region. Again, y'all, if we were to have done the whole thing, we would have had 99.7. But we're only looking at half of it, right? So we're going to take 99.7. We're going to divide it by 2. 99.7 divided by 2. Did anybody get 49.85? Boom. And there you go. Right? And that number would go right there. Okay. So obviously, guys, when you're going to, like in this case, if you're going to go buy a car, you definitely want to fall in that region, right? You want to pay less than what the average price is, right? You don't want to pay more than the average price, right? You want to pay less. Okay. So let's keep working here and let's see what else we got. Okay, let's see. The mean is 17,500. Here's my average. Okay, standard deviation is 500. Use the same rule to find the percentage of buyers who paid more than 8,500. Okay, so y'all, I'm looking for everything that way. Okay, more than, I'm sorry, than 18,500, more than that way. All right, so look, y'all, let's see if we can figure this thing out. If I look at the picture, y'all, just the way the picture is drawn, and I were to come up here and come here and come here, everybody in the red, would you guys agree that everybody in the red would be 95%? Okay. Y'all, when we're talking about percentages, does anybody know what percent would represent the whole percent? Everything together? What do you think? Like if you get every question right on your test, what grade do you get? 100. So the whole thing, y'all, would be 100%, right? We know that the red area is 95. Y'all, what that's telling me is that everything this way and everything that way, these two pieces together have to add up to 5%, right? Because the whole thing is 100, the rest of it has to be 5. We need to take that 5% and cut it in half, and we'd have 2.5% that way, and we would have had 2.5% that way. We were interested in the people who paid more than 18,500, and that would be 2.5%. Okay. All right, let me see what else we got here. Boom. Okay, another problem. Again, still dealing with the price of a car. Okay, let's see. The average here, y'all, 17,000. Boom, there we go in the middle. Standard deviation is 1,000. We want to figure out what is a percentage of buyers who paid less than 15,000. So look, y'all, again, just like we did this before, we're looking for everybody over here. Okay. So y'all, first thing I'm going to do is I'm going to say, look, let me come up here. Let me look at this piece. Everybody in here adds up to 95%, right? The whole thing obviously is 100. So when we take away that 95%, we're still left with 5%. Y'all, 5% is going to be split, between those two pieces. We're looking for the red one, right? So we just take 5% and divide it by 2, 2.5%, right? All right. Y'all, one thing I want to mention is like in this, I'm going to do this next problem right here, and it says scores on the GRE. So, y'all, right now, most of us right now are far away from taking the GRE. But just to let you know, the GRE is once you get your bachelor's degree, right, in whatever field you want to do, and then you decide you want to go and get a master's degree or a PhD, just like most of us probably took the TSI test, or some of you might have taken the ACT, there's another test you take to go to graduate school, and it's called the GRE. Okay. So that's what that test talks about. That's the school that you're going to go to because you want to get a PhD or you want to get a master's degree, something like that. Okay. So let's take a look at this problem. And it says scores on the GRE are normally distributed with a mean or an average of 511. Y'all, first thing I'm going to do, I'm going to come down here to my chart. And I'm going to write, I'm going to write the number 500. Oh, come on. There we go. Okay. I'm going to write the number right here, 511. Okay. Now, look at what they're telling me. My standard deviation is 128. Okay. Y'all, we want to find the percentage of people who took the test and scored between a 383 and a 639. So the first thing I'm going to do, y'all, I'm going to take my score, 511, Look at our standard deviation. It's 128. Let's add 128 and let's see what number we get. So when I add these numbers together, y'all, that's going to give me 9. That's going to give me 3. That's going to give me 6. So this number right here, y'all, that number is not 636 Omar, but 639. Okay. Y'all, I'm going to stop right there because that's the bigger of my two numbers. Let's do that again. Let's take 511 and now let's subtract 128. So if I take my calculator, 511 minus 128, y'all, I'm coming up with 383. So that's telling me that number right there is 383. And I'm going to stop right there. Why? Because that's the other number that I got. So y'all, they're asking me what percentage of people scored in this range. And if I want to know what percentage of people scored within that range, wouldn't that be 68, right? Because it tells me, boom, right there. Y'all, one thing I want to mention, when I made these notes together, y'all, these problems, I got them directly out of the homework. But not every one of these problems has this little chart, okay? So when you're doing your homework, I would keep, this little chart by you so that you can kind of figure out what it is you got to do, okay? Look, let's try another one. We'll do the same thing here. Okay, so it says scores in the GRE are normally distributed with a score of 527 and a standard deviation of 131. Okay, so first thing I'm going to do right here in the middle, y'all, this is 527. Okay, now we want to figure out, find the percentage of people who are taking the test who score between 134 and 527. So y'all, since 527 is my bigger number, I'm not going to be adding the standard deviation. I'm going to be subtracting it. So let me take my calculator. Let's see, what's 527 minus 134? And I'm coming up with 393. So that tells me this number right here, 393. Okay. Y'all, I'm trying to get to 134. So I'm going to, or you know what? My standard deviation was not 134. My standard deviation was 131. Sorry, y'all. Boom. Let's fix that right here. So let's see, 527 minus 131, 396. There we go. Oops, 396. Much better. Okay, let me subtract 131 again. So 396 minus 131, I'm coming up with 265. Okay, so that is that number right there. Okay, I still haven't gotten to 134. So I'm going to do this again. I'm going to take 135, and again, I'm going to subtract 131. That's 4, that's 3, that's 1. Boom, there we go. 131. Okay, y'all, we are looking for that percentage, right? Remember, y'all, from here to here would have been 99.7, but we're only looking at half of that. So let's take 99.7 and let's divide it by 2, and I'm coming up with 49.85. And that's really all I got to do here. Okay, so again, here's another one, y'all. Intelligence quotients. So this is the IQ test. Okay, so look what they're telling me. The average is 171 right here. Boom, 171. Standard deviation is 18. We want to find the percentage of people who have an IQ above 189. Remember above, y'all? That means more. So look, we're going to take 171. We're going to add 18 to it. That's 9, that's 8, that's 1. Okay. So this score right here, y'all, This score right here is 189. I'm looking for that percentage. Okay. Trying to see if I can find that percentage. Again, look, y'all, if you look right here in the middle, that middle block right there is 68%, right? Remember what the whole thing represents, right? The whole thing represents 100%. Let's subtract that middle piece right there. So 100 minus 68 should be something like 32%. So 32% of the numbers, y'all, are going to fall on the sides of that red area. Okay, on the sides of that red area. So what I want to do is I want to find half of that. Half of that should be, boom, 16%. Okay. All right, let's try another one. Okay. Now on this IQ test, the score was 169, so I'm going to put that right there. My standard deviation in this problem was 13. Okay. We want to know what is the percentage of people who have an IQ below 156. So we're going to take our average, which is 169. We're going to subtract 13. That's 6. That's 5. That's 1. Okay. So again, y'all, right here, 156. We are looking for everybody over there. Okay. Just like we did before, y'all, everybody within this box is 68%, right? So we got to say, look, the whole thing would be 100. We're going to subtract 68. That's going to give us 32. We're going to find the lower half. So all we got to do is take 32 and divide it by 2. And again, y'all, we should still get 16. Right? Okay, so look, let me keep scrolling and let's see what else we got here. Okay, so y'all, the last thing we're going to talk about is this idea of something called the Z-score. Okay, and so we use in statistics, guys, we use Z-scores. Z-scores is sort of like a standard way of talking about standard deviations. Okay, and so what we're going to do is we're going to figure out how do we compute a Z-score. So y'all, we got a little formula right here. The Z-score just says we're going to take the data item minus the average. We're going to divide it by the standard deviation. Okay, so it says, look, a set of data averages is normally distributed with a mean of 40, standard deviation of 10. We want to convert 60 to a Z-score. So y'all, they use a little symbol down here. They're calling it Z of 60. Okay, this is what we're going to do. We're going to take the data item. The data item is the new score they gave me, 60. We're going to subtract the mean. The mean, we wrote it down right here, was 40. We're going to divide it by the standard deviation of 10. Okay. So first thing I'm going to do, 60 minus 40 should be what, 20? And 20 divided by 10 is 2. What this tells me, y'all, is that a score of 60 is 2 deviations above the mean. Why is it above? Because that 2 there, y'all, is positive. Okay. All right, look, let's try another one here. A set of data items, normally, again, distributed with a mean of 40 and a standard deviation of 10, convert 80 to a Z-score. Okay, so the first thing we're going to do, we're going to write 80. We're going to subtract the mean, which is 40. We're going to divide it by the standard deviation of 10. Okay, so 80 minus 40 is still 40. And if you take 40 and divide it by 10, positive 4. So a score of 80 is 4 deviations above the mean. Okay, above the mean. Guys, I'm going to do like a problem in a minute where we kind of get the idea of what is this really telling me? Like, what does that mean above the average, below the average, whatever it happens to be. Okay, so look, let's do this next one here, z of 30. Okay, my average is 30. My standard deviation is 8. How would we actually convert 30 to a z-score? So we're going to take 30 minus 30 again, divided by 8. 30 minus 30 is still 0, and 0 divided by 8, y'all, is just 0. What does that tell me? That a score of 30 is 0 points away from the average. Why? Because it's the average itself. Okay. All right. A set of data items is normally distributed with a mean of 70. Okay, so here's my average. Standard deviation, again, 10. Let's convert 60 to a z-score. All right, so z of 60 is going to say we're first going to take our number 60. We're then going to subtract our average, and we're going to divide it by 10. Anybody know what 60 minus 70 is? Negative 10. Very good. Negative 10 divided by positive 10, isn't that negative 1? Y'all, because it's negative 1, what we would say is a score of 60 is 1 deviation below the average. Okay, why below? Because it's negative. Okay, so y'all, the last two problems, I think it's 2 problems. Yes, the last 2 problems that I have here, this example right here, guys, kind of puts the context of like, what do we use standard deviation for? Does anybody get nervous when you go to the dentist because they got to clean your teeth, right? You're afraid you're going to have a cavity. You've heard of things like root canals, right? We get nervous, right? So look, scores of dental anxiety range from 0, meaning like ni fu ni fa, didn't bother me at all, or 20, like I'm really nervous, my heart's beating 100 miles an hour, okay? Scores are normally distributed with an average of 12 and a standard deviation of 14. Find the z-score of this on the dental anxiety scale. So somebody has a level of 19. We're going to do this. We're going to take 19. We're going to subtract 12. We're going to divide it by 4. So 19 minus 12 is 7. And again, y'all, if you take your calculator and you take 7 and divide it by 4, is anybody getting 1.75? Yeah. Okay, so we're a little nervous there, y'all. Remember, look at what the high score being extremely nervous going to the dentist is. It's 20. Where are we on a scale of 20? I'm at a 19, man. I'm feeling this, right? I'm really feeling this. I don't want to go. That's what it's basically telling us. Okay, let's do another one. Again, same sort of setup, y'all. If I'm not nervous at all, 0. If I'm really nervous, 20. Okay, my mean is 12. My standard deviation is 4. How would we feel if we were at a 14? I don't know. Let's figure it out. We're going to go 14 minus 12 divided by 4. So 14 minus 12 is 2 divided by 4, 0.5. Not really. A little bit nervous, but not too much. Okay. A little bit more than the average. That's all it's basically telling us, y'all. Okay. All righty. Guys, dry your eyes because that's the last thing I'm going to teach you. Right? Let me stop recording. Boom. Here we go.